Some materials allow electric current to pass through them, whereas other materials do not allow an electric current to pass through them. On the basis of this property, we can divide all the material around us into two groups: conductors and insulators. Let us discuss about water conductors and water insulators one by one. Let's begin with conductors. Those materials which allow electric current to pass through them are called conductors of electricity. All the metals are conductors of electricity. Silver metal is the best conductor of electricity. Copper and aluminium metals are also good conductors. Electric wires are made of copper and aluminium because they are conductors of electricity. Other metals like iron, steel, mercury, and gold are also good conductors. The metal alloys like steel, brass, and bronze, etc., are also conductors of electricity. All the objects made of metals or metal alloy are also conductors. For example, the objects such as coins, keys, pins, aluminium foil, sewing needle, and iron nail are all good conductors of electricity because they are made of metals or their alloys. A non-metal called carbon in the form of graphite is also a conductor of electricity. The thin black core of our pencil is usually called pencil lid. Now this pencil lid is made up of graphite. So pencil lid is a good conductor of electricity. The human body does not conduct electricity as good as metals. The human body conducts electricity to some extent. So the human body is a poor conductor of electricity. A person gets electric shock on touching an uncovered electric wire carrying current because some electric current passes through his body. Water also conducts electricity to some extent. So water is also a poor conductor of electricity. Those materials which do not allow electric current to pass through them are called insulators. Insulators are actually the non-conductors of electricity. Rubber, plastic like polythene, PVC or bakelite, asbestos, wood, glass, mica, cotton, jute, wax, paper, etc. are all bad conductors of electricity. Even the gases are bad conductors of electricity, so we call them insulators. They do not allow electric current to pass through them. All the objects made of insulator material are called insulators. For example, rubber. The outer covering of electrical wires is made of plastic because plastic is an insulator. Plastic covering does not allow electric current to pass through it. Air is an insulator. Conductors and insulators are equally important for us because they are both useful in their own ways. Conductors are used to carry electricity or electric current. For example, electricity is carried in our homes by copper wires or aluminium wires because copper and aluminium are conductors of electricity. The electricity used in our homes can be dangerous. A person will get an electric shock if he touches a bare wire carrying electricity. It can even kill a person. Insulators are used for safety. Insulators protect us from getting electric shocks. Insulators allow us to handle current-carrying wires, switches, plugs, sockets, and other electrical appliances safely. For example, the electric wires covered with insulators like plastic or rubber. An electric cell has two terminals. They are marked as positive and negative. And a torch bulb has also two terminals which are marked as positive and negative. When the two terminals of a cell are connected to the two terminals of a torch bulb by using wires, the electric current passes through the filament of the bulb and it starts glowing, giving off light. In other words, the torch bulb lights up when its metal tip and metal case are connected to a cell through wires. Actually, when electricity or electric current from the cell passes through the filament of the bulb, the filament gets heated too much. The filament becomes white hot and starts giving light. So it is the heating effect produced by electricity from the cell which makes a torch bulb work and produce light. Thus, a torch bulb converts electricity into light. Sometimes an electric bulb does not glow even if it is connected to a cell by wires without any gap in the circuit. This can happen if the bulb has got fused. When the filament, the thin wire that we were referring to of a bulb, gets broken, the bulb is said to be fused. Thus, a fused bulb has a broken filament. A bulb may fuse due to normal wear and tear of the filament or when too much electricity is passed through it suddenly. A break in the filament of a bulb means a break in the path of electricity between the terminals of the cell. So, when we have a fused bulb in a circuit, the circuit gets open or broken and electricity cannot pass through it. Since no electricity passes through the broken filament of a fused bulb does not light up even if it is connected properly to a cell. We have made the electric circuit by using metal wires such as copper wires because copper wires are conductors of electricity. That is, copper wire can conduct or carry electricity through them. If, however, we make a circuit using cotton threads or jute strings, then the bulb will not glow. This is because the cotton threads or jute strings are non-conductors of electricity, or as we call it, insulators. That is, cotton threads or jute strings cannot conduct or carry electricity through them. Thus, electricity can only flow if there is a complete circuit made of conductors such as electric wires, bulbs, etc. If we want to turn on or turn off a bulb or for that reason any other electrical appliance easily, we should connect a switch in the circuit. The switch is a simple device which is used to open or close a circuit. An open circuit means that there is a break or gap in the circuit, whereas a closed circuit means that it is a complete circuit having no gap. So, we can also say that a switch is a simple device which breaks a circuit or completes a circuit as desired by us. A switch works by opening and closing a gap in the electric circuit. When the switch is in the off position, the gap opens up in the circuit due to which electricity stops flowing in the circuit and hence the electrical appliance stops working. On the other hand, when the switch is turned on, the gap in the electrical circuit is closed and a complete circuit is made. Due to the complete circuit, electricity starts flowing in the circuit and electrical appliance will now start working. Thus, the purpose of using a switch is to turn on or turn off an electrical appliance by closing the circuit or opening the circuit respectively. The switches used in the circuits of electric bulbs and other electrical appliances in our home work on the same principle of closing or opening the circuit, but their designs are more complex. Some of the electrical appliances which have inbuilt switches are table fan, room heater, room cooler, mixer, grinder, the table lamp, washing machine, hair dryer, drilling machine, torch, television, radio set, microwave oven, etc. Electric fuse is a safety device which is used to limit the current in an electric circuit. The use of a fuse safeguards the circuit and the appliances connected in that circuit from being damaged. A fuse is a short and thin piece of wire of uniform area of cross-section and high resistance to the extent that it passes current only up to its safe limit. It is made up of a material of low melting point so that it may easily melt due to overheating when current in excess to the prescribed limit passes through it. Generally, an alloy of lead and tin is used as the material of the fuse wire because its melting point is low and resistivity is more than that of copper and aluminium. A copper or aluminium wire is unsuitable for use as a fuse wire because they have high melting point. Moreover, the use of an ordinary copper or aluminium wire as a fuse must be avoided as it is very thick, so its resistance will be low and it will pass current higher than its safe limit. A fuse wire permits the flow of current through it only up to a certain fixed limit, which is called the current rating of the fuse. At this limit of current, the heating in the fuse wire is sufficient to melt it. The thickness of fuse wire depends on its current rating. Higher the current rating, thicker is the fuse wire. Nowadays, instead of a fuse, a miniature circuit breaker or MCB is used for each individual circuit. If due to short circuiting or some fault, a heavy current flows in the line, the MCB falls down to switch off the circuit in a very short time, which is in the tune of 25 milliseconds. The MCB is then again raised after repairing the fault in the circuit. Thus, the use of MCB is easier than a fuse because it avoids the inconvenience of connecting a new fuse wire, and it is much safer due to its quick response. Each electric appliance is provided with a 3-core flexible cable. The insulation on the 3 wires is of different colors. The old convention of colors of insulation is red for live, black for neutral, and green for earth, while the new international convention is now brown for live, light blue for neutral, and green or yellow for earth.